Hello everyone, this is Sravanthi, working as Assistant Professor, Department of Chemistry in Institute of Aeronautical Engineering. Today we are going to discuss about problems on calculation of air quantity required for complete combustion of fuel. So before discussing the problems, we discuss the main point. We should remember these points. After that you can easily solve how much amount of air required for complete combustion of fuels. So first, what is the meaning of fuel? So fuel is a combustible substance. During burning process in the presence of oxygen, it produces heat energy. It is called fuel. So it contains main constituent is carbon. So this process is called combustion. So here theoretical calculation of minimum air required for complete combustion of fuel. So generally the main elements present in the fuels are carbon, hydrogen, oxygen and sulfur. Generally most of the fuels containing these elements carbon, hydrogen, oxygen and sulfur. So on combustion of fuel, these elements are converted into gases like carbon dioxide, water, sulfur dioxide, etc. So during combustion means fuel, if in case carbon or hydrogen or oxygen, sulfur present in this fuel and interacts with atmospheric oxygen or oxygen, it gives combustion products and releases heat energy. This process is called combustion of fuels. Generally, most of the fuels containing carbon, hydrogen, oxygen, sulfur, etc. elements. So during burning process in the presence of oxygen, if in case carbon reacts with oxygen, then gives carbon dioxide. If in case hydrogen present in that fuel, so hydrogen reacts with oxygen, then gives water. If in case sulfur present in this fuel, so sulfur reacts with oxygen, then gives sulfur dioxide. So these are the combustion products are formed when these elements carbon, hydrogen, oxygen or sulfur present in fuel during burning process in the presence of oxygen. It forms this type of combustion products. So for efficient combustion, sufficient quantity of air must be brought into intimate contact with the fuel. Complete burning of fuel, it requires minimum amount of oxygen. Sufficient amount of oxygen required for complete combustion of fuels. So the amount of air and oxygen, required for the complete combustion of a fuel can be determined by considering the below points, following the points. So here, first step 1 is write combustion reaction equation. Generally, these are the following steps must be followed to calculate the amount of air required for complete combustion of fuel. All these steps most important for numerical point of view. So first step 1 is write combustion reaction equation. Write combustion reaction equation. For example, carbon present in fuel. So what is the combustion reaction? Carbon reacts with oxygen, then gives carbon dioxide. So what is the molecular weight of carbon? 12. Oxygen here 32 and carbon dioxide 44. So here first write the combustion reaction equation. If in case carbon present in this fuel, you can write the equation is carbon plus oxygen gives carbon dioxide. Combustion product is carbon dioxide. Next step 2. So from this equation, so calculate the amount of oxygen required. From this equation, calculate the amount of oxygen required by the elements or compounds present in the fuel. So what is it meaning? From this equation, calculate the amount of oxygen required by the elements or compounds present in the fuel. So that means here, for example, 12 parts by weight of in this reaction. For example, 12 parts of carbon or 12 kgs of carbon requires 32 kgs of oxygen for complete combustion of 1 kg of fuel or 44 kilograms of fuel burning. So 12 kilograms of carbon requires how many kilograms of oxygen? 32 kilograms of oxygen. So in this we find out how much amount of oxygen required for the complete combustion of elements or compounds present in the fuel. This is step 2. So it is easily we can identify by write on the chemical reaction or combustion reaction. Next, step 3. If oxygen is present in the problem. If, for example, oxygen is mentioned in the problem. So it subtract the weight or volume of oxygen already present in the fuel from total oxygen required by the other elements or compounds. So what is the meaning of step 3? If in case oxygen present in the fuel, it is given in this problem, for example. So we can subtract that already present in the oxygen present in fuel is from total amount of oxygen required for the complete combustion of fuel or by other elements or compounds. So this is the step 3. And next step 4 is, since nitrogen, carbon dioxide and water, if in case present in this fuel or combustion products are formed, so these are do not burn, so they do not require any oxygen. So therefore their values is mentioned in the problem, it can be ignored. So for example, if in case nitrogen present in fuel or nitrogen value given in the problem, so nitrogen do not participated in this combustion because it doesn't have any calorific value, do not involve in combustion reaction, so doesn't require oxygen. So if in case this percentage present in the given in this problem, we can ignore that one. So in the same way, if in case nitrogen, carbon dioxide and water, anyone present, that percentage present given in that problem, we can ignore because doesn't require oxygen, not participated in this combustion reactions. Next, step 5. So finally, calculate the amount of air required by the fuel by multiplying 100 by 21 if volume percentage with total amount of oxygen required and 100 by 23 if weight with total amount of oxygen required. So what is the meaning of step 5? Generally air contains 21% of oxygen. Air contains 21% of oxygen by weight, by volume. Air containing 21% of oxygen, that means by volume we are taking. So we can write here 100 by 21 with the amount of oxygen required. The amount of oxygen required. Or otherwise, air containing 23% of oxygen. So here we are taking by weight. If in case in that problem given the elements percentage is in kilograms or by weight. So in that case we are using this formula 100 by 23. So if in case air contains 23% of oxygen by weight, so you can write here 100 by 23 with total amount of oxygen required. Next, step 6, excess of air or excess air for combustion. So more than the theoretical amount of air is necessary in practice to achieve complete combustion. So the excess air is expressed in percentage of the theoretical air. Excess air is expressed in percentage of theoretical air. So it's equal theoretical air into 100 plus excess air by 100. This is the formula mainly used for the excess air is expressed in percentage of theoretical air. So in this case we are using this formula. So these are the most important point we should remember before calculation the how much amount of air required for complete combustion of fuel. Numerical purpose, all these points are most important. So what is the step 1? So we have to write down the reaction, combustion reaction. Next, step 2, from this combustion reaction, we can calculate how much amount of oxygen required for complete combustion of elements or compounds present in fuel. And next, step 3, if in case already oxygen percentage given in that fuel, so we can subtract that oxygen percentage from the total amount of oxygen required for complete combustion of fuel. And next, step 4 is, if in case non-combustible substances like nitrogen, carbon dioxide or water, if in case present in that fuel or that percentage given in that problem, we can ignore because they doesn't have any calorific value. That means they do not participate in combustion reaction. So doesn't require any oxygen. So we can ignore that one. Next, step 5 is, if in case air contains 21% of oxygen. So in this case, we can write 100 by 21 with total amount of oxygen required. Or otherwise, air contains 23% of oxygen. So in this case, we can write 100 by 23 with total amount of oxygen required. So next final step is the excess of air is expressed in percentage of theoretical air. So it's equal, how can we calculate this one? Theoretical air into 100 plus excess of air by 100. So by using this formula, we can calculate the expression percentage of theoretical air. So now we'll discuss problems based on that how much amount of air required for complete combustion of fuel. So what is the first problem? Calculate the minimum of air by weight required for the complete combustion of fuel having the following composition by weight. So here carbon percentage is 82, hydrogen percentage is 13, oxygen percentage is 3%, and carbon percentage is 0.82 kilograms, and hydrogen percentage is 0.13, and oxygen percentage is 0.03. So that meaning go here, it's in this problem, it's given carbon, hydrogen, oxygen percentages. So we can convert it into kilograms because here we given weight, by weight we are taking. So we can convert this carbon, hydrogen, oxygen percentage into kilograms by weight. That means, so carbon percentage is carbon weight is 0.82 kilograms, hydrogen weight is 0.13 kilograms, oxygen weight is 0.03 kilograms. So now let's discuss weight of air required for complete combustion. So what is the formula we are using for this weight of air required for complete combustion? So here we are taking weight. So generally air contains 23% of oxygen. So we can write here 100 by 23. This is the formula used for this one. So it's equal 100 by 23 into 32 by 12 into C plus 8 into H minus O by 8 plus sulfur. So this is the formula used for weight of air required for complete combustion. Here what is the meaning? Previously already we discussed previous classes. So what is the meaning of 32 by 12? 12 kilograms of carbon requires 32 kilograms of oxygen. And here carbon means how much percentage of carbon present in that fuel. For example, here in that problem given 82%. So we can convert it into kilogram. Its percentage, weight is 0.82 plus 8H minus O by 8 and plus sulfur. So previous classes already we discussed why are writing this formula. So all these are, that means 23% of air or oxygen present in air. So we can write here 100 by 23 plus 32 into C, 32 by 12 into C plus H minus O by 8 into 8 plus sulfur. So this is the formula used for weight of air required for complete combustion of fuel. So now in this formula we can substitute the percentage of carbon, hydrogen, oxygen and sulfur. We can substitute in this formula. So here now we'll get 100 by 23 into 32 by 12 into carbon percentage is 0.82, carbon weight 0.82 plus 8 into hydrogen weight is 0.13. Hydrogen weight is 0.13 minus oxygen weight is 0.03 by 8 plus sulfur percentage or sulfur weight is not given in that problem. So we are taking here 0. So after calculation we'll get it's equal 100 by 23 into 3.197. 3.197. So after calculation finally we'll get 13.9 kilograms. So weight of air required for complete combustion of fuel is it's equal 13.9 kilograms. Problem is, so the percentage composition of sample of coal is C equal, that means carbon equal 88%, hydrogen equal 5%, and oxygen equal 4%, and nitrogen equal 2%, and sulfur 1%. So now calculate the minimum weight of air required for combustion. Calculate the minimum weight of air required for combustion and calculate the percentage composition of dry products by weight. Calculate the percentage composition of dry products by weight. So how can we calculate the minimum weight of air required for complete combustion? First one. So here carbon percentage is 88. So we can convert it into weight because here we can calculate the minimum weight. So we convert the percentage into kilograms. So carbon weight is 0.88 kilograms. 0.88 kilograms. And oxygen percentage given in that problem 4%. So we can convert it into kilograms. We'll get 0.04 kilograms. 4 by 100 is equal to 0.04 kilograms. And hydrogen percentage given in that problem is 5. So when we convert it into kilograms, we'll get 0.05 kilograms. And the same with sulfur is 1%. So we can convert it into kilograms into 0.01 kilograms at 1 by 100 is equal 0.01 kilograms. In this way, you can convert it into percentage to kilograms. So next, we'll calculate the weight of air required. Weight of air required. So what is the formula we are using for this one? So 100 by 23 into 32 by C, 32 by 12 into C plus H minus O by 8, 8 into H minus O by 8 plus sulfur. So this is the most important formula used for the determination of weight of air required. So how much amount of air required for complete combustion of fuel? Generally we are using this formula. So after that we can substitute the percentage of carbon, hydrogen, sulfur, oxygen in this formula. Then we'll get, so 100 by 23 into, here 23 means here we are taking weights. So air contains generally 23% of oxygen. So we can write here 100 by 23. Clear? So it's equal 100 by 23 into 32 by 12 into, what is the carbon weight here? 0.88. So we can substitute in this formula 0.88 plus 8 into H hydrogen weight is 0.05. So we can take here 0.05 minus, and oxygen weight is 0.04. So we can substitute here oxygen weight is 0.04 by 8 plus sulfur weight is 0.01. So we can substitute in this formula carbon, hydrogen, oxygen, sulfur weights. So after that we'll get 100 by 23 into 2.717. 2.717. So after calculation finally we'll get 11.81 kilograms. 11.81 kilograms. So the weight of air required or minimum weight of air required for complete combustion of fuel. So how much value we'll get in this formula, in this problem? 11.81 kilograms of air required. And next we can calculate the percentage of composition of dry products by weight. So here dry products, that means carbon reacts with oxygen. So in this case it gives carbon dioxide. And one more thing important is here nitrogen percentage also present in this formula, in this problem, given in this problem. But we cannot calculate because how much amount of oxygen required for complete combustion of fuel. In this case we cannot consider nitrogen percentage because nitrogen doesn't require oxygen, or otherwise it do not participate in combustion. So if in case nitrogen percentage given in that problem, we can ignore. We can ignore because it doesn't require any oxygen or not participated in that combustion reaction. So it is negligible. It is most important here. Next. So if carbon reacts with oxygen, then formed byproduct is carbon dioxide is formed. So how can you calculate this one? So 44 by 12, see here. So carbon, if in case what is the formula? Carbon reacts with oxygen, then form carbon dioxide. So carbon molecular weight is 12 and oxygen molecular weight is 32 and carbon dioxide molecular weight is 44. So 12 kilograms of carbon required. How many kilograms of oxygen? 32 kilograms of oxygen. So carbon dioxide molecular weight is 44 and carbon percentage is here given. Carbon weight is 0.88. So you are taking 12 kilograms of carbon burning. In this case, combustion product weight is, carbon dioxide weight is 44. So 44 by 12 into, and what is the percentage weight of carbon present in this fuel? 0.88. So it's equal 3.227 kilograms of carbon dioxide formed. 3.227 kilograms of carbon dioxide formed here in this during that reaction. When carbon reacts with oxygen, then form combustion product. What is the weight of that product? 3.227 kilograms. In the same way, we can calculate the sulfur dioxide. So sulfur reacts with oxygen, then form sulfur dioxide. So sulfur molecular weight is 32 and oxygen molecular weight is 32 and sulfur dioxide molecular weight is 64. So molecular weight of sulfur dioxide by 64 here by 32. Sulfur molecular weight is 32. So that means 32 kilograms of sulfur burning, then form combustion product sulfur dioxide is 64. Weight of the combustion product is 64 into how much percentage of sulfur present in that given fuel. So what is the weight of sulfur present in the given fuel given in that problem? 0.01. So it's equal 0.02 kilograms. So total amount of sulfur dioxide formed in this combustion product weight is 0.02 kilograms. And nitrogen in the sent to air plus nitrogen in the fuel. So I can calculate this one. It's equal 77 by 100 into how much percent present in that fuel? Weight 11.81 plus 0.01 nitrogen already present in the fuel. So it's equal 9.104 kilograms nitrogen into present in the fuel. Total it's equal 9.104 kilograms. So total byproducts are carbon dioxide, sulfur dioxide and nitrogen. So it's just now we calculated. Carbon dioxide weight is 3.227 and sulfur dioxide weight is 0.02 kilograms and nitrogen weight is 9.104 kilograms. So total weight of this dry products are 12.351. So you can convert it into percentage. That means 3.227 by 12.351 into 100. So in this case, you'll get 76.13 percentage. In this way, you can convert it into weight to percentage. So weight of the dry product by total weight of dry products into 100. Finally, you'll get this percentage. How much percentage of carbon dioxide present in fuel is 26.13. And sulfur dioxide is 0.162 percentage. And nitrogen is 73.71 percentage present in the fuel. And next, one more problem we'll discuss. Calculate the amount of theoretical air by weight and volume. Calculate the amount of theoretical air by weight and by volume required for complete combustion of 2 kg of coke. 2 kg of coke assuming 100% carbon content. Assuming 100% carbon content. So here you can calculate the theoretical air by weight. By weight means here we are using 100 by 23 because the air containing 23% of oxygen. And also volume required. So air containing 21% of oxygen by volume. So in this case we are using 100 by 21. We can write here. So for complete combustion of 2 kg of coke. So you are assuming 100% of carbon content. So your solution is, if in case carbon present in that fuel, what is that reaction? Combustion reactions, carbon reacts with oxygen, then gives combustion product is carbon dioxide. So here 12 kgs of carbon required, 32 kilograms of oxygen. So already we know that 12 kilograms of carbon requires 32 kilograms of oxygen. So here weight of oxygen required for complete combustion of, in the problem given, 2 kg of coke. 2 kg of coke. So how can we calculate it? So 2 kg means coke means here 32 by 12 into, here 32 by 12 means here 12 kilograms of carbon required, 32 kilograms of oxygen. So 2 kilogram of coke require how much amount of oxygen? So how can we calculate this one? 32 by 12 into 2. It's equal 5.333 kilograms. So weight of oxygen required for complete combustion of 2 kg of coke, it's equal 5.333 kilograms. Now amount of air required for the complete combustion of 2 kg of coke. So how much amount of air required by weight we are taking here. So we are using formula is 100 by 23 into the percentage of carbon present in that given fuel, 2 kg of fuel, or otherwise 2 kg of coke requires how much amount of oxygen. So just now we calculated here 5.333. So we can substitute it here. 100 by 23 into how much amount of air required for 2 kg of coke burning? So 5.333. It's equal, we'll get 23.2 kilograms. So the amount of air required for complete combustion of 2 kg of coke, it's equal 23.2 kilograms. Or otherwise in the formula, in this problem given that total amount of air required by volume also. So here the volume of air required for complete combustion of 2 kg of coke. So volume is generally air contains 21% of oxygen. So in this case we are writing 100 by 21, but in this case we are writing 100 by 23. Okay, so here volume of air required for the complete combustion of 2 kg of coke. So how can we calculate this one? It's equal 100 by 21 into same here. How much amount of air required for 2 kg of coke burning? So in that case we are getting here 5.333. So we can substitute in this 100. So it's equal 100 by 21 into 5.333. It's equal, final formula is, final value is 25.4 meter cube. So here the volume of air required for the complete combustion of 2 kg of coke, it's equal 25.4 meter cube. So in this problem we can calculate the amount of theoretical air by weight or volume required for complete combustion of 2 kg of coke. So here weight of oxygen required for complete combustion of 2 kg of coke is 5.333. And total amount of air required for complete combustion of 2 kg of coke is 23.2 kilograms. And the volume of air required for complete combustion of 2 kg of coke is 25.4 meter cube. So in this way you can calculate the minimum amount of theoretical air by weight or volume for complete combustion of 2 kg of coke. Now let's discuss one more problem. Based on that, how much amount of air required for complete combustion of fuel. So here determine the volume of air. Determine the volume of air needed for complete combustion of 1 cubic meter of producer gas having the following composition by volume. So here hydrogen percentage is 25% and carbon monoxide percentage equal 15 and methane percentage is 5 and nitrogen percentage is 52% present in that given fuel. So the combustion equation or for hydrogen is, so hydrogen reacts with oxygen then gives combustion product is water. Combustion product is water. So here for example here we are taking what is, you can calculate determine the volume of air. So here 1 volume of hydrogen, it requires 0.5 volume of oxygen. 0.5 volume of oxygen. So in that case combustion product volume is 1 volume. So first write down the chemical reaction of combustion chemical reaction. Next, from that reaction, we can calculate how much amount of air required. So here you can calculate in the volume. So 1 volume of hydrogen requires 0.5 volume of oxygen. So in this case, combustion product volume is 1. And the same way, next carbon monoxide. So carbon monoxide present in that fuel, it is reacts with oxygen, then gives carbon dioxide. So here also 1 volume of carbon monoxide requires 0.5 volume of oxygen. So in this case, combustion product volume is same 1 volume. 1 volume. Next product is methane. So methane reacts with oxygen, then form combustion products are carbon dioxide and water. So in that case, 1 volume of methane reacts with 2 volumes of oxygen. And in that case, it forms combustion products, carbon dioxide and water. Volumes are 1 volume of carbon dioxide and 2 volumes of water form. So first write on the chemical combustion reactions in volume. Next. So volume of oxygen needed for complete combustion of 1 meter cube of gas. So it's equal 0.25. So we can convert this percentage into kilograms. So here 0.25 percentage of hydrogen and carbon monoxide is 1.5, and so 0.15 and 5 percentage of methane. So we can convert it into kilograms. If in case nitrogen present in that fuel, we can ignore because it is not participated in combustion reaction, doesn't require oxygen for combustion. So we can ignore if in case nitrogen percentage given in that problem. So here nitrogen percent given in this, so we can ignore. So here, so volume of oxygen needed for complete combustion of 1 meter cube of gas. So here hydrogen percentage is 25. So we can convert here 0.25. And here how much amount of oxygen required? 0.5. So we are taking here 0.5. So in the same we are taking, so this is the percentage of hydrogen, and whatever given in that problem, hydrogen, carbon monoxide, methane. So you can write here hydrogen, carbon monoxide and methane weights, kilograms. Okay, next, how much percentage of oxygen required given in that reaction here? So 0.25 is the weight of hydrogen given in that fuel. Given fuel into 0.5 is the 1 volume of hydrogen required, 0.5 volume of oxygen. Plus, so the carbon monoxide weight is 0.15, it requires oxygen is 0.5. Plus, methane weight is 0.05 and it requires volume is 2 into 2. So it's equal, we will get finally after calculation 0.3 meter cube. 0.3 meter cube. So volume of air needed for complete combustion. Volume of air needed for complete combustion. So it's equal 100 by 21 into 0.3. Volume we are taking. So that's why we are writing here 100 by 21 because air containing 21% of oxygen. So volume of air needed for complete combustion. It's equal 100 by 21 into 0.3. Just to calculate this value. Volume of oxygen needed for complete combustion of 1 meter cube of gas. So we can substitute here 0.3. So after calculation finally get 1.428 meter cube. So the volume of air needed for complete combustion is in this problem is 1.428 meter cube. So in this session we'll learn about what are the main steps involved in this, how much amount of air required for complete combustion of combustion reaction, how much amount of air required. So in this, what are the problems based on that? We should remember first, before solving this problem, we should remember all 6 steps. After that, we can calculate, it makes calculations very easy. I hope understood all. So thank you.
Like, share and subscribe. Hit the bell icon for more updates.